Welcome back to the TechMoto channel and our series of tutorials for beginners in electronics. In today's video we're going to be looking at AC and DC power, and we're going to touch on bridge wave rectifiers and transformers. So what is AC and DC? Well, AC is alternating current or voltage and DC is direct current or voltage. Now we're going to jump into a few examples to explain what that means. Okay, so let's add a power supply, and our load today is going to be a light bulb. We'll add some wires either side, connecting them together, and then we'll pass some power through the circuit. Now you can see that power is flowing in one direction, so this is direct current. As long as the power continues to flow, the light bulb will stay lit. Okay, let's take that current away and replace the power supply with an alternating power supply. You'll see that the current starts flowing around the wires in one direction, then it changes direction, and then it changes direction again. The power alternates through our load. Interestingly, a light bulb will work with power flowing through it in either direction, and so is suitable for alternating current. This is perhaps easier to see if we draw a graph with volts on the vertical axis and time on the horizontal axis. In the case of DC current, the current remains the same. You can see a straight line here at a set voltage, and you can rely on a stable power supply. So now let's clear the graph and do the same thing for alternating current. So the voltage starts at 0 and climbs up to your maximum power rating. So in the UK that'd be 240 volts, in America that would be 125 volts. Once it hits 0, it goes down to minus 240 volts or minus 125 volts, and then climbs back up to 0. From 0 to 0 to 0 is classed as a cycle, and in the UK our power supply cycles 50 times a second. Now, whilst alternating current is perfect for light bulbs, what about other devices that require DC power from your mains? For a computer or a television to work, not only do you need direct current, but you need to reduce the voltage. To do this, we use a bridge wave rectifier. The first thing we want to do is capture the positive side of the AC signal and cancel out the voltage when it drops below 0. We therefore need to cancel out the voltage when it goes below 0 and keep the voltage when it is above 0. To do this we use a configuration of diodes, because diodes only allow current to flow through it in one direction. Here's an example of a bridge wave rectifier with an alternating power supply. The first example we're going to show you is current flowing in one direction. It leaves the power supply and goes into our bridge wave rectifier. It gets blocked by certain diodes, allowed through other diodes, through the DC load, and then back to the power supply. If we now change the polarity of the power supply so the current is going in the opposite direction, the circuit will work in much the same way, with some of the diodes blocking the electrical current and others allowing it through. Notice that the current flows through the DC load in the same direction as the previous example. Now this gives us exactly what we want, only the positive side of our AC power supply. However, you'll notice that this is not a constant DC power supply. It goes up and then down to 0 and then back up to your maximum voltage. The best way to iron out this signal is to use capacitors. Now, as we know from previous videos, capacitors store charge and then release it slowly. By strategically placing capacitors on the output of our bridge wave rectifier, as the voltage goes up, it stores charge in the capacitors. Then, when the power drops back to 0, the capacitor takes over by discharging its contents, taking over momentarily from the power supply. Every time the voltage increases again, it recharges the capacitor ready for the next cycle. Using a combination of a bridge wave rectifier and capacitors, you can smooth your signal to a DC output. Electronic devices on the market don't use the full AC power that comes from your outlet, and so we need to reduce the amount of power coming through the circuit. This is done with a step-down transformer. Okay, so let's take a piece of wire and we'll add a power supply either side. Current will flow through that cable. When current flows through a cable, it creates an electromagnetic field around the cable. Now, if we remove the power supply, the electromagnetic field fails. But if we add an external electromagnetic field to the outside of the cable, then current flows without a power supply on the cable itself. Now we can use current flow and electromagnetic fields to our advantage by using a transformer. By wrapping insulated wire around a solid core, we can create a primary coil on the left-hand side and a secondary coil on the right-hand side. The primary coil has more wire than the secondary coil. When we pass current through the primary core, it creates an electromagnetic field between the two coils. The secondary coil then picks up that electromagnetic field, but it's only a percentage of that magnetic field and reduces the voltage. So that's it. We've got everything we need. We have our AC power source. We have our step-down transformer. We then have our bridge wave rectifier, which provides us with a DC current. If you open up any electronic device that runs on DC, you'll find a bridge wave rectifier, but the diodes won't be in a diamond configuration. They're usually next to each other in parallel, with two of the diodes facing in one direction and the other two in the opposite direction. You're also likely to see several other components, which include capacitors and resistors and so on, everything the circuit needs to operate. So that's it. Next time you plug in your phone or your laptop or any other device and you see that great big black box that's at the end of the wire, that's what's inside. And that brings us to the end of this video. I hope you enjoyed it. I hope it was useful. Please do like, subscribe, and I'll see you in the next one.